this computer. Okay. Now we're going to lecture 5. See, why don't we do the whole course like this? Because you guys would not be able to do it. This is a review. Gotta go.
Yeah.
Only because you understand it already can we do this fast. Okay, lecture 5. And we're into this big topic of arrays. Too much here to possibly remember it all, but let's try anyway. Present. And arrays. So you actually write the word declare. This is in Bash. We're still in Bash now. And I took this from this website. I'm giving credit where credit is due. I did alter it a little bit, but basically the whole thing is from there. But it was a good explanation, so why not use it? But you're allowed, you're allowed to use other people's stuff if you give them credit, in my opinion. So, I mean, not credit, if you say that you're using their thing. Indexed arrays. So there's 2 kinds of arrays, there's associative arrays and indexed arrays. You're used to indexed arrays more, but in other languages, there are, other than C++, there are something called associative arrays, and you declare them with a capital A. What's the difference? Well, the difference is that you can make an array where the field, where the indexes of the array are actually strings and have no real order. And so, for example, well, no, we'll start with regular arrays. If I can also just create an array like this. If I write in parentheses foo bar, then it knows that I'm creating an array because I gave it 2 things in a parentheses. And then if I do my array of place 0, it's going to give me foo. And my array of place 1 will give me bar. But I can also use the word declare minus a, little a, and then do the same thing. Now, the default, as you see, is minus a. Let's do some more stuff with arrays. If I want to print out all the values, I can use the @ symbol. And if I could also do it with a star, because the star is like wildcards. So it's going to match everything, so it'll essentially be the same thing. There's a slight difference. And here I go through all the elements of the array, and I print each element. In other words, here I'm going to print each element too. Here I'm also going to print each element, but I'll print them on different lines. Here I'll print them on the same line. Okay. Here, if I use the star, it'll still print on the same line. That's the difference. The @ symbol will give me as different. Notice here the loop only runs once, because essentially I'm giving back the result of this whole, as a string, I'm giving the whole array. Here with the @ symbol, I'm treating it as element by element. So it's a small difference. So for example, what else can I do? I can make a loop. Here's in Bash, if you want to do C style, we showed you already that you can do a range like 1.10. But I can also do the C style where I equals 0 as long as I is a 5, I plus plus. But in order to do that, I have to use the double brackets, double parentheses, whatever you call it. Then I can use this special, it's like a new feature of Bash. Double brackets, double parentheses. Here it's not. Here's regular old stuff. But why don't I write why don't I write $1 here? Because I wrote the $1 here, really. The variable, and then that's the whole thing. Okay, so for what am I doing here? Print the keys instead of the values. So here, if I would have just without the $, without the bang, it's called a bang, without the exclamation mark, it's really called a bang. In Unix, it's called a bang. Without the bang, it would just print me all the elements of the array. But with the bang, it's going to print me the opposite of the elements. In other words, their indexes, which is 0 and 1. So it's interesting. Even though I never declared the size of the array, it knows how many are defined and therefore only gives me those indexes. Now I can also make an array, like I said, associative array. Here's an example of associative array, which I didn't tell you yet, but here it is. I say, I give it the key that I want. Foo is the key and the value is bar. Bar is banana. Bar is the key and the value is coconut. So I made an associative array, and now if I say print me the, if I say bang my array, print me the indexes, it's going to print bar and foo. If I would remove this bracket bang, it would give me bananas and coconut. So this is useful for places where you want to have, let's say, associations. That's why it's called associative array, like zip codes and the town name. So I want to have zip codes, not as strings, let's say, or maybe that's a bad example because of zip codes, but I could start. There's no order in the zip codes. I want to have just like the zip code and the town name, or the reverse, town names and their zip codes. So the index will be the Montclair, and then the zip code will be whatever the zip code is, or there might be multiple ones though, whatever, something like that. Or what other examples you could have, like the content of my refrigerator. I think that was an example. Bananas is the key, and then the value is how many bananas I have. 1, 2, 10. So then I've stored like double information, not only what things I have in my refrigerator, but how many I have in my refrigerator. And I used a single dimensional array for that. So that's a very useful thing in programming, associative array. Okay. So adding elements, getting the size of an array or the number of elements, you just use the number sign in front of the array name, but you got to put the ampersand symbol inside of the, you got to say, take all the elements. Otherwise, if you wouldn't do that, if you just give it like just my array, then it would give you the length of the first element of the array. Because if you just gave it my array without any braces or brackets after it, then it would assume you mean the first one. And then the number would no longer mean the number of elements, but the number of letters in that string. So in order to make it mean the number of elements in the array, you got to give it the whole array. So therefore, you've got to write the ampersand, is that an ampersand? Whatever that symbol. Is it called ampersand? I forget now.
No, it's not ampersand. Ampersand is the.
Oh yeah, ampersand is the and symbol. It's the, what is this called in Hebrew? Was there a name for that?
In Hebrew, it's the shluda, but in English, it's just at.
Yeah. Actually, in Hebrew, the technical word is kruchit. The colloquial term is strudel. Okay. So where are we? So yeah, my array contains so and so number of elements, where it's the number of things in the array. And now adding elements. So let's say you started the array with foo bar and you want to add baz. So you say plus equals. And it'll automatically get the next increment. And now if I print the whole thing, I'll see the whole thing. And now I'm going to have 4 things in my array. Okay. And if it's an associative array, for example, or my array place foo is bar, then first I declared the blank array, but as I made it associative, then I said the first element is bar. Now, how am I going to make new ones? Well, I'm going to have to give them both the key and the value because it can't know what the keys are supposed to be as associative array. How do I delete? I just have this unset command. I can unset a particular element. And now the really weird thing is that if I unset the first element, which is bar, foo is 0th element. So if I unset this one, it's now going to have foo and bar. But what are the indexes going to be? The funny thing is the indexes are going to be 0 and 2, because the 1 is still like, it never was used. Like I unset it, so it's not there, but it didn't mean that this guy moved. So if you think about it, really these non-associative arrays are really a kind of associative array where just the key is a number. In other words, it doesn't have, there's no magic going on here. It just removes this one. So the array, it's an associative array where one key is 1 and one key is 2. Or sorry, one key is 0, one key is 2. And I can do the same thing with unset in an associative array. Deleting a whole array, I can just do unset the whole array. And if I echo it, I'll get nothing. Let's see where else. Okay. More array examples. Here I make a whole bunch of array with a bunch of things. And if I say the number of elements in the array, number of all the array is obviously going to be 1, 2, 3, 4, 5. The number of array 2 is going to be the size of the 2 element, which is this one, 6, 5, 4, 4. The size of it is 4. So the number means just like either the size or the length. There's the number associated with it. The number of the whole array, well, here it's going to assume, like I told you before, the first element. So it'll give me the length of this one, or 6. Because I forgot to write the at symbol. If temp equals, now what does this mean? Temp equals the whole array, the third one. So assign the variable temp all the values in the array from index 3 and on. But it'll be one variable. So if I do print temp, it's a single variable, but it has in it like a concatenated list of all the elements of the array from the third on. This is the third, 0, 1, 2, 3. Echo temp 0 to 1. What does that mean? So now I got my temp, and here it all is. And I say 0, print variable temp from index 0 for 1 character length. Remember, if I hadn't, this one was 3 on. I didn't have another colon here. Here, there is another colon, 3, 1, which is 1 character length. So it'll print me, again, the variable temp from index 0. So you can look at a variable and say, well, it's actually an array of letters. And the 0th letter is 4. And 1 letter long will be 4. So it'll give me the letter 4. The first 4. So again, you can use these same operators, these colons, on an array, in which case it means elements in the array, or on a string, a variable, which means the letters in the string. And if there's only 1 colon, then it means that from where to start, and it ends at infinity. And if it's 2, then where to start and how many to count. Not where to end, but how many to count. It's important. If I would, in other words, it's how many to count, not the number to end on. Okay, temp equals, this will create temp as an array of 2 elements by using this special symbol parentheses around it. Instead of being 44, 5, 4, 5 as one long string, the second 2 elements, I'm doing the exact same thing that I did before over here, right? This line here, the 4th from the bottom and the bottom are exactly the same, except by putting parentheses around it, I get, I treat it as an array. Printing section of array and copying an array. So we already actually did that. But here, here's my big array. And I say print, we just did this, I guess, really. Print 1 to print, starting at 1, 3 long. So starting at 1 is 2, 3, 4, and 3 long, 1, 2, 3. So it'll end at 45, 45, which is what I said. To copy an array, you need to iterate. So there's 2 ways to copy it. One way, actually, I should change this slide. To copy an array, you can iterate over each element, like in C++. But to save time, you might try something like this. Declare my array to be Q and then the whole array. But again, we said that won't work, and you have to do it like with the parentheses. Because why won't that work? It'll make Q, it'll basically make an array of one element, because it's still, on the right side of the equals, it still views that as one element. So you got to use the parentheses. And then there's this double, now there's, we already, I mean, I sort of briefly showed you, but there's a single test. You know, we call this test. But with one bracket, it's also called test. And with two brackets, it's also called test. So what we do is the two brackets we call new test. And the single bracket we call regular test or test. We already talked about it, where you can say is a string equal to, or does the string contain, this means, the word my. Now, this means it's a string. This doesn't work in single brackets. In single brackets, we didn't see that. We saw that list of all the things you could do. You could just say, is it equals, not equals, greater than, less, but you couldn't say, does it contain? There was no such thing. So they added a new feature called, instead of rewriting test, they left test. They added a new version of test, which is exactly like test, but it has a few new features. And one of them is that it can do this contains. So you have to write double brackets now. And then you can say contains my, and then it'll work. But if you didn't want to, how would you do it the old way? You would say if, and then I'd echo the string, and then I'd grep it quietly for the word my. And if it was true, then this whole if would be true, and then it would print it's there. Jobs is a concept in Unix where we talk about tasks or programs that you started running, but then you suspended them. And you put them into the background. You did that. One way of doing that is by doing Control Z to suspend them, and then typing BG, and it puts into background. If you type FG, it'll bring it to the foreground. Well, what if, but only, you can only type FG if you have something in the background. And you can only type BG if you have already suspended something. You can't type BG. Now I don't remember how to write BG. Right. So in other words, you do Control Z, and if you type FG, it'll come back up. It'll start again. You suspended it, and now you unsuspend it with FG. FG means foreground. BG means background. So after you suspended the job, it froze it, kind of disappeared, but it's still in the running. It's still in the background, but not running. If you want to bring it back, but not in the foreground, you want to still be able to type on your shell. That's what being in the foreground means. It's taking up your shell. You can't type anymore. So if you want to bring it back, but have it run in the background, you can do BG after you did Control Z. But you can also do it in one line just by writing the name of the program you want to run. And then instead of just hitting enter, you write an ampersand and then hit enter. And that means run it, but run it in the background so it won't take up your shell. xargs is for running arguments that you received in the standard input. In other words, ls, let's say, produces a list of files. Now, I'm going to send those files through the pipe, and I want to run file on it. But file is not built to accept. File is only built to work file and then a list of file names to run it on. File, remember, if you remember what file does, it tells you whether the file is an ASCII file or it's a binary file. And if I want to know if all these, I want to run file on all the files in my directory, I might write ls pipe file. But file isn't built to receive things from the standard input, which is what the pipe would do. I want them to have them on the right side. I want it to be as though I wrote file, space, and then file name, file name, file name, file name, file name, all the way on the right here. So how do I get this ls to throw them here? So what xargs does, xargs is kind of like a assistant for me. It takes the standard in that came here and then runs file and passes it those arguments one by one. It actually passes it one by one. So xargs will actually run the command file many times. It grabs that input, holds onto it, runs file, and then passes it each time one of those arguments. So for example, here, what does this command do? This command means find. We learned about find. Find a file in directory temp whose name is core, whose type is a regular file, and then just print it out. Print it to the screen. So that's just going to find them and print it to the screen. But then I send it to a pipe. And what I want to do is rm-f. I want to delete those files. Any file named core. But if I just write pipe rm-f, rm is not built to take things from the standard input. So I use xargs so that it becomes as though I wrote bin rm-f and then file name that I got from this print. More examples. If I do, for example, here's WC is a program that actually does accept from the standard in, but also could accept on the right side. So here you see an example where I show the difference. If I do ls f1, f2, f1, so it's going to receive, well, what is it going to receive? It's going to receive a standard input, which is f1, f2. And when you do ls of f1 and f2, it's just going to print the names of the files, which are already written here, which are f1 and f2. So ls f1 and f2 is just going to print f1 and f2. So it's as though I sent to the standard input of WC f1 and f2. So it tells me, oh, you just sent me 2 lines with 2 words with 6 letters. Because remember, there's always there's like a return, an enter at the end of each line. Even though, yeah, it'll print them 2 different lines. So WC just takes, it doesn't tell me the word count of the file, it tells me the word count of the strings F2 and F2. So if I wanted to be on the right side of the WC, I can do it like this. xargs, and then it's as though I wrote WC file 1, file 2, and it gave me file 1, file 2, and the total. So that's what, actually, that's the way actually, it doesn't, I take it back. It doesn't run the command, it doesn't run WC multiple times. When I said before, it runs, you know, bin rm multiple times. It doesn't. It runs it once, but with a lot of strings over here. So to here, it runs WC. So I wrote WC F1, F2, which will run those 2, which will run like this. And it'll actually tell me the word count of F1 and F2, which is what I wanted. Here's another file, here's another find example. Find in the current directory anything that's any files of type file, regular file, and grep it for the word George. And notice there's no grep what George. What, there's missing a field here. What file am I grepping? I'm grepping the files that I got over here. They've been put on the right side. Now here I explain a subtle point that what if the file names, like I did like ls over here, what if the file names, what if I did ls star or something? And some of the file names have spaces in it. So if there's a space in the file, then WC will think it's 2 different files. What if the file name is my file with a space? So it'll think there's a file called my and it'll think there's a file called file. But there's really one file called my file. How is it going to work? So what we do is we tell find to print zeros, which means print the null at the end of each file name. So instead of printing my file, it'll print my file null. And then when we do here -0 R, it means run this command with the and run it on each name ending in null, as opposed to each name ending in space. So that will enable this to work. All right, it's 6:30. Let's take another break, and we'll come back in like 15 minutes for the lab.